Hi, everyone. My name is Raid Mahbub, and I am a cloud solution architect within the security tech strat team at Microsoft. Today, I'm joined by Yuning as well as Dishan, and today we're going to be talking about trusted, compliant AI systems at scale. Today, we will move through these 9 sections. We start with the threat landscape to frame the problem, then build each defensive layer: secure system design, responsible AI, observability, identity, data protection, threat protection, and red teaming, before we end with our key takeaways. Each section relates to each other, so by the end, you will see how these layers work together as a complete security framework. Let us begin by understanding the threat landscape. What are we actually defending against? This section frames a security problem. We will look at the AI threat taxonomy, understand how the threat model has evolved with agentic AI, and establish a prioritized risk register. The goal is to ensure that everyone in the room shares the same understanding of what we are defending against before we actually start building the defenses. Agentic AI introduces new layers of complexity, technically, operationally, and from a security perspective. We're now operating in an ever-evolving AI threat landscape where organizations must contend with 4 critical risk areas: data, threats, identity, and regulations. Data, of course, is at the core of AI. AI even generates a lot of AI data itself, and it requires a lot of data to train. With greater data comes greater risk. AI systems can leak sensitive data, make decisions based on inaccurate and poisoned inputs. Identity is another emerging challenge. AI agents need to be treated like digital employees, with clear identities, access controls, and activity tracking. Threats targeting AI systems are also escalating. Attackers are crafting new techniques, from prompt injections to model evasion and poisoning. And finally, regulations are catching up. Governments around the world are implementing new compliance requirements around AI transparency, fairness, and security. So together, these 4 forces are changing the AI threat landscape. If left unaddressed, they create serious risks. These statistics paint a clear picture of the challenge. 82% of leaders expect to deploy agents in the next 12 to 18 months, but the security concerns are equally stark. 80% of security leaders cite leakage of sensitive data as their primary concern when adopting AI. 88% of organizations are worried about indirect prompt injection attacks, and 55% of leaders lack understanding on how AI will be regulated, adding compliance uncertainty to the mix. Here we can see the top 10 threats for AI agents obtained from industry sources such as OWASP and MITRE Atlas. There's a few different categories here, so let's go through them. Threats 1 and 2 are regarded as critical, meaning they can lead to direct agent takeover by a hostile party to perform malicious actions. This includes prompt injections, jailbreaks, and excessive agency. Following this, we have high-level threats like insecure tools, sensitive data disclosure, insecure outputs, data poisoning, and supply chain compromise. These are major concerns which could impact the data or tools that an agent relies on. And finally, we have threats such as denial of service, misinformation, and model theft. These are in the medium category as they relate to resilience risk. Now let's take a look at the generative AI threat map. This is how it looks before the rise of agentic AI. It organizes the risks across 3 layers. At the top, we have user interaction risks such as sensitive information disclosure and shadow IT. In the middle, application layer threats such as prompt injections and data leakage. And at the bottom, model and training data risks. With the inclusion of agentic AI, the threat map expands significantly. Notice the new risks that appear in the middle layer. These are unique to agents. And these are things such as intent breaking, agent drift, tool misuse, and memory poisoning. So these threats exist on top of everything we saw on the previous slide. The attack surface has grown because agents do not just generate text, they also take actions, call tools, and interact with other systems autonomously. Across this session, we will be covering 3 major pillars of AI security. First is observe, because you cannot control what you cannot see, which makes it fundamental to have the full picture of all agents in your organization. Next is govern, meaning establishing guardrails for agents and users and having the processes in place to be audit ready. And finally, secure agents, because just as any other asset in your environment, agents also need strong protections, from identities and access to safeguarding the data that they will use and defending them against threats and vulnerabilities. Our unified solution to facilitate this is Agent 365. Now let's take a look at what it can do for you. Agent 365 is the new enterprise control plane for managing all your organization's agents securely at scale. Many of its governance features are available directly within the M365 Admin Center, as we can see here. So let's take a closer look. Within the Overview dashboard, I can see a complete view of the key metrics for every agent running in my organization, including agents built across different platforms. As we can see here, we're covering Copilot Studio, Foundry, and third-party. We can also see where and who are publishing the agents, as well as the active users over time, and the top trending agents by user activity. Lower down, we can see some top actions that are pending for me as an AI admin. These agents are waiting to be published. These agents have risks associated with them, emerging from Defender, Entra, and Purview. Some agents do not have owners, which needs to be required for human in the loop, and agents with exceptions are ones that are having issue in runtime. Now we can go to the All Agents tab. This is where I can see a whole list of my agent fleet, and I can see all the agents in my organization, regardless of where they came from or on which platform. The registry will auto-consolidate all agents that were built within our platforms, as well as ecosystem partners that have been integrated with Agent 365 SDK, and anything else that has been registered manually. We can click into an agent to see what sort of information will appear within this Java Fabric Supplier agent. We see a description and some details. We can also see which users are able to access the agent, in this case specified to certain groups. Within security and compliance, we see some information coming in from the Microsoft Security Suite. And in data and tooling, we can see the capabilities that the agent will have in terms of its connections and various knowledge sources that it might be using. With permissions, we can see the specific granular permissions that are available. And with activity, we can see the user trends for that specific agent over time. Now we can go into the agents at risk filter. Here we can see a list of agents that have at least one risk associated with them from either Defender, Entra, or Purview. So let's take a look at the comms agent. Within the security and compliance section, we see that there are two risks that are being emerged from Entra. One is the agent has abnormal sign-in frequency, and the other is that the agent was accessed by a risky user. As an admin, I can come in and block the agent very simply by clicking there. Now we can head to the agent map, and this is a different graphical view of looking at your agent estate. We can take a look at a specific agent and see which other agents it's connected to with these red lines. After we click into the agent, we can see other information about it, including the fact that it has two risks associated. Now we hit to the requests area, where we can see the agents that are yet to be published. First, we will go onto the agent, see the various information coming from security, compliance, and other permissions, and then we can enter the request itself. First, we would specify who is this agent going to be published to. Is it all users or is it specific users? Next, we can apply a policy template. These are actually policies that are emerging from Defender, Entra, Purview, SharePoint, and other sources that can be bundled together so you can apply it at scale across your agents. And then permissions. It's very important that the AI admin looks at all the permissions before accepting. And then we hit publish, and the process is complete. Now we shift from understanding the problem to building solutions. This section covers defense in depth, trust zones, and secure by default orchestration patterns. The key principle is that security must be designed in from the start, not bolted on after deployment. The responsibility for managing AI risks varies depending on the type of service you use. You may have seen this diagram before. It is our shared responsibility model, where we split between the service provider, in this case Microsoft, and the customers who are building AI applications. With SaaS applications like M365 Copilot, Microsoft handles the majority of safety features. Your responsibility is more focused on user training, identity and access, and data security. With PaaS solutions such as Foundry, Microsoft provides platform-level security and responsible AI commitments. We scan open models onboarded to the model catalog to verify they are free from bad code. And then you, as the users, will take responsibility for the application design, the plugins, infrastructure, and safety systems. With IaaS, where you bring your own model and almost everything else, model safety, tuning, data governance, and application security will be your responsibility. Microsoft will provide the infrastructure security foundation. So across these, it's very important to be aware of what you are responsible for and what Microsoft is responsible for. And this leads us to Zero Trust, which is not a new model, but applying it to AI requires extending 3 core principles. The first is to verify explicitly. Continuously evaluate the identity and behavior of agents at every interaction. Assess every application being used, deployed, and developed. Use least privilege. Restrict access to models, prompts, plugins, and data sources to only what is needed and also to who it's needed by. And third, assume breach. Design AI systems to be resilient to prompt injection, data poisoning, and lateral movement. Assume each prompt can have malicious intent. And by applying these principles, you can effectively design your security and governance controls for AI transformation. So let's see what this looks like as an architecture. In fact, this is the full Zero Trust architecture extended for AI. On the left, you have identities, and now you can notice that agents join users, devices, and workloads as a first-class identity type. On the right-hand side, AI resources join the traditional set of apps, data, and infrastructure. The familiar policy enforcement points still apply: strong authentication, zero trust access, network filtering, threat protection. The key change is how these now control and secure AI agents and resources. Meanwhile, the outer ring shows the governance layer: compliance, security, and productivity optimization, all feeding continuous telemetry. We can now drill into the specific layers at work here. The defense in-depth strategy across these 4 areas. At the model layer, at the top, intentional model selection, supply chain governance, these things to ensure that the model can do what you need and nothing more. The safety system layer, input and output filtering, agent guardrails, logging and observability, and abuse and anomaly detection. Then the application layer, treating agents as microservices, deterministic human-in-the-loop controls, least privilege, and system messages as a reinforcement. The positioning layer, clear disclosure to users, capability transparency, and secure UX patterns. Each layer reinforces the others. If one layer fails, the next one will catch the issue. This is the architectural principle that underpins everything else in the session. And to ensure that you can create your AI systems in a safe, trustworthy way, Microsoft is here to help you start secure and stay secure. With our AI development platforms like Foundry, we enable developers to fine-tune their own prompt guardrails, while Copilot Studio, we have baked-in security features to provide peace of mind. Meanwhile, Microsoft Security Suite is integrated across all of these to cover threat protection, data security, and of course, identity and access management. With these integrated tools at hand, we hope you can confidently adopt AI securely. And now I will hand it over to Yuning to talk more about how Microsoft ensures AI safety with our responsible AI principles.
Now, let us talk about responsible AI and compliance in a very practical way. This is not just about having a nice policy document. For production agents, trust has to show up in the way the system behaves every day. We'll start with the 6 Microsoft responsible AI principles and then make them more concrete. You've probably seen these 6 principles before, but agents make them feel more real. Fairness means that agents should not trust users differently or choose tools in a biased way. Reliability and safety means that when the agent is unsure, it should slow down, ask for help, or fall back safely. Privacy and security means protecting data at every step, in the prompt, in the response, and in every tool call. Inclusiveness means the experience works for different users and needs. Transparency means people know what they're working with AI and understand its limits. And accountability means we can trace action back to an owner. So the next question is, how do we make these principles part of day-to-day operations? Responsible AI works best when people, process, and technology reinforce each other. A simple way to think about it: discover, protect, govern. Discover the harms and residual risks, protect with content filters, prompt shields, PII detection, and severity classification. Govern with a use case registry, defender monitoring, audit logging, and recurring red teaming. None of this is a one-off activity. According to the Microsoft AI ecosystem, they become repeatable reinforcement patterns. So, responsible AI moves from a good intent to something teams can act to at home. Let me show you what plays out across the different Microsoft AI platforms. Foundry, Copilot Studio, Microsoft 365 Copilot all contribute to the same trust model: block unsafe inputs, protect outputs, govern access, and keep evidence for audit. Foundry gives the builder deeper configuration where they need it. Copilot Studio brings safety controls into low-code and business-built agents. Microsoft 365 Copilot adds admin-governed controls such as sensitivity labels, connector policies, plugin controls, and enterprise boundaries. Microsoft AI Platform enforces responsible AI consistently from custom development to low-code agents to enterprise Copilot experience. And regulation is another big reason why this ecosystem approach matters. Regulation is moving quickly, and it is not limited to one region. When we see the EU AI Act, NIST guidance, ISO standards, and country-specific frameworks all moving in the same general direction. The names and details vary, but the expectations are consistent. Manage risk, be transparent, show accountability, and keep evidence. So, rather than chasing every rule one by one, it's better to build a governance model that can adapt. And that's where Compliance Manager comes in. It helps translate the shifting landscape into something your teams can actually add on. Purview Compliance Manager helps reduce the manual work of turning regulations into action. It can pull in requirements from frameworks and translate them into controls, service actions, and assessments. The practical benefits is consistent. Instead of every team interpreting the same requirements differently, you get a more structured way to track controls and evidence. Once these controls are in place, observability helps us to see whether they are actually working. Put simply, trust observability is how we avoid flying blind once agents are in production. It is the difference between saying we have controls and actually being able to see whether those controls are working. Let's start with 3 pillars. Explainability helps people understand why the AI behaved in the way it did. What inputs did it use? What context mattered? Why did it take that path? Monitoring tells us whether the system is behaving correctly right now. Quality, safety signals, drift, anomalies, and policy violations. Accountability gives us the audit trail, so if something goes wrong, we can investigate and prove what happened. You need all 3 pillars to close the loop. Different teams care about different parts of observability. IT wants to know what agents exist, who owns them, and what they're allowed to do. Developers want feedbacks on whether an agent is safe to ship and whether they stayed aligned after changes. Security team wants the bigger risk picture across apps, agents, data, identity, and threats. Agent 365, Foundry, Entra, Defender, and Purview provide the shared foundation instead of forcing everyone to build their own view. We see this spans from code to runtime. We know that agents oversight is not just the developer's job, and it's not just the security job. It is shared across developers, IT, and security. Agent 365 helps security and IT manage agents to do at runtime, including oversight and guardrails. Foundry control plane helps developers build, evaluate, and operate agents while still aligned to the enterprise identity and the security requirements. Agent 365 is designed for several personas. IT admins want controls and governance. Business leaders want outcomes and ROI. SecOps analysts want to detect the threat quickly. Data security admin want to protect the sensitive information. Identity admins want clean access controls. CISOs want a view across the estate. Observability should not live in a corner. It needs to show up in the tools each role already uses. Foundry then connects the governance model back to how agents are actually built. Microsoft Foundry is the place where many teams build and operate AI apps and agents. It helps connect models, knowledge, and tools into a runtime that can be observed and governed. For builders, that means that they can move fast without stepping outside enterprise controls. For security and governance teams, it means the agents being built are visible, manageable, and connected to Agent 365, Defender, Purview, and Entra. We will show you a quick demo on the governance of AI agents in Microsoft Foundry and Agent 365. We will start in Foundry, where Java Retail manages its AI agents. Here we can see several agents already deployed. If I switch over to Operate Experience, I get a single pane of monitoring these agents. You will notice the compliance alert has been raised. This is important because governance isn't just about keeping agents running, it's about making sure they're operating safely and according to policy. I can quickly see things like success rate, token usage, run volume, and estimated cost. So instead of jumping between different dashboards, operation teams have everything they need in one place. Next, if we look at assets, we can see all of the agents, models, and tools being used. This gives governance teams a complete inventory of what's running in the environment. For example, I can review which guardrails are applied to each agent and identify any compliance gaps that need remediation before they become a risk. You can see policy compliance violations on the assets, guardrails on the model deployments, and the quota allocation. Now, let's move from a project-level governance to organization-wide governance with Agent 365. From the Microsoft 365 Admin Center, I can see all agents across organizations, regardless of where they were built. Right away, the dashboard highlights the things administrators care about most: pending access requests and agents without assigned owners. These are common governance issues that can easily appear as AI adoption scales. If I go to all agents, I get a complete inventory of every agent in the organization. One feature I particularly like is the map view. It gives a visual representation of the entire agent estate. By filtering to AI Foundry, I can instantly isolate all Foundry-based agents and drill into a specific one, such as the Sava Shopping Assistant. Opening that agent, I can immediately see governance actions such as the ability to block the agent organization-wide if a security or compliance issue is discovered. The Security and Compliance tabs is integrated with Purview, helping organization monitoring agent activity, protect sensitive data, and identify compliance gaps. We can also review pending deployment requests to ensure the new agents follow the right approval process. Finally, governance extends beyond agents themselves. In the Tools section, I can see MCP servers and external capabilities available to the agent, and if necessary, block access centrally across the organization. To wrap up, Foundry helps you build, operate, and monitor agents, while Agent 365 provides enterprise-wide governance, visibility, security, and compliance. Together, they give organizations confidence to scale AI agents responsibly across the business. With that, I'm going to hand it over to Dishan to talk about agent identity.
Here's the thing about agents. They act. They don't just answer questions. They do things. And anything that does things in your environment needs an identity. Not a borrowed one, not a shared one, its own. This section is about building that foundation right. Get this wrong, and you have handed your AI a skeleton key. Get it right, and you have got auditability, control, and security that actually scales. Users, apps, devices. We give them all an identity. Attach policies, log what they do. That's the model. Agents don't fit neatly into any of those buckets. They act on behalf of users, behave like apps, and unlike apps, they evolve. New capabilities, growing blast radius, no deployment required. The question isn't whether agents need identities. Of course they do. The question is how. That's what Entra Agent ID solves. Entra Agent ID gives every agent a proper identity. And once it has that, it plugs straight into the frameworks you already have. Conditional access, RBAC, audit logs, same system, extended to cover agents. Without it, policies are patchy, audit trails are messy. And when something goes wrong, you're guessing. With it, you have answers. So on the left, shared service account. 3 agents, one set of credentials. It's the path of least resistance, and it's a nightmare. Something goes wrong. You don't know which agent did it. You want to revoke access, you take down all three. On the right, each agent has its own identity, scope to exactly what it needs. You can audit any one of them independently. You can pull one agent's access without touching the others. And you have a clear line of accountability from every action back to a specific agent. Let's look at what makes the right side possible. A quick analogy here. Cookie cutter and cookies. The cutter is your blueprint. Every cookie from that cutter is identical. Same shape, same recipe, consistent every time. But once baked and packaged, each one gets its own barcode. Same origin, individually trackable. So that's the model. Blueprint gives you consistency. The unique identity gives you accountability per agent. Same mold, individual audit trail. So once your agent has an identity, how does it actually authenticate? There are three flows, and the right one depends on what the agent is doing. First, the autonomous flow. No user involved at all. The agent wakes up, gets a token from the blueprint, and access resources as itself. Nobody's sitting there waiting. The agent just runs. The second is on behalf of. This is when a user triggers the agent. They sign in, make a request, and the agent acts as that user. Their token combines with the blueprint token to produce a scope resource token. The agent can only see what that user can see. Third is the agent user account flow. It is for platforms like Exchange or Teams that genuinely require a real user identity with the mailbox and presence. Use it only when the platform forces your hand. The quick rule: autonomous for background work, on behalf of when responding to a user, agent user account only when the platform demands it. Now, before you build any of this, you need to design the blueprint and agent identity right. Let's talk about what that looks like. So 6 practices here. Let me walk through them quickly because each one has a reason behind it. Start with a blueprint before you write any code. I know that feels backwards, but if you build the agent first and wire up identity later, you are retrofitting permission into something that's already running. One identity per agent. No exception. Shared identities are nightmare. Every blueprint needs a sponsor and an owner on day 0. Not optional. The API will literally reject the request if either field is blank. Name things consistently. Agent, team, function, and put the purpose. Push policy to the blueprint, not the instance. As example, conditional access. Configure them once at the blueprint level. Every agent inherits automatically. And when you need a kill switch for an entire fleet, disable the blueprint. And last, never register AI agent outside the agent ID framework. If you must, use Agent 365 SDK to give it an identity. A plain app registration might feel quicker. It isn't. You lose sponsor accountability, dedicated audit entries, lifecycle controls. That's exactly how Shadow AI starts. With that, let's move into a quick demo. One of the key benefits of giving an agent its own identity is that we can extend the same security controls we already use for users and devices to agents as well. In this demo, I will show you how easy it is to create a conditional access policy that automatically blocks high-risk agents from accessing resources. We are currently on new conditional access policy page. First, let's give the policy a meaningful name. Next, I will define the target of this policy. In this case, I want it to apply to all agents. For target resources, I will select all resources to ensure comprehensive coverage. Now, let's configure the condition. The risk level is what we're interested in here. So I will set the policy to target agents that are identified as high risk. Next, we define the access control. Since these are high-risk agents, the appropriate action is to block access. That's it. We are ready to create the policy. The policy is now deployed. With this risk-based conditional access policy in place, any agent that is determined to be high risk will automatically be flagged. Now let's validate the policy is working as expected. To do that, we will navigate to Identity Protection and select Dashboard, and then View Risky Agents. Here we can see the agents that have been flagged as risky based on the risk detection and policies we have configured. This demo shows how agents' identity integrates with existing zero trust controls, enabling organizations to govern and protect agents in the same way they protect users and devices today. AI changes data protection. It's not about locking down storage anymore. AI reasons over sensitive data, summarize it, surface it at scale. Traditional control weren't built for that. You need visibility into what data exists, how it classified, and where it flows before AI moves somewhere it was never supposed to go. So here's the tension. Data is AI's fool and the number one target for attackers. Developers want to unlock it. Security team want to lock it down. Both are right. The goal isn't to pick a winner. It's to do both, govern sensitive data and still accelerate AI adoption. That's what this section is about. Your existing governance process were designed for humans and traditional apps. Agents break those assumptions. How do you govern an agent your compliance tool don't know exists? Who's accountable when one autonomously accesses sensitive data at 2 a.m. with no human in the loop? Do you have visibility across the dozen of agents already spreading across your teams and tools? These aren't hypothetical. They are the gaps that turn into incidents. So how do you actually close those gaps we just talked about? Start with the shift in how you think about data security. Data is the prerequisite for AI adoption, not a nice to have, a prerequisite. How fast your organization can move with AI is directly tied to how well you understand, govern, and protect your data. If that foundation isn't solid, every AI project built on top of it carries the risk with it. And security can't be a one-time checkpoint anymore. Data has to be discovered, classified, governed, and protect everywhere it lives. And it needs to stay protected as users and agents work with it. The other shift is that protection has to follow the data, not just guard the perimeter. Across applications, the browser, the network, external system, policy need to be enforced consistently through a single control plane, not patched together from separate tools. And AI itself play a role here. An AI-native approach to data security improves classification accuracy, reduces the manual burden, and adapts to specific context of your environment. By default, not as an add-on. Data security, governance, and compliance have historically lived in separate tools, separate teams, separate policies. That fragmentation is exactly what creates blind spot when AI enters the picture. Purview brings all three together. Protect data through its life cycle, unlock its value responsibly, manage compliance without the manual overhead. Three discipline unified, but for an environment where AI is acting on your data every day. Agents create data loss risk two ways. First, sensitive data surface in a response to someone who shouldn't see it. Familiar problem. Second, an agent autonomously sends an email, creates a document, updates a record. No human reviewed it. That's the one that catches organization off guard. The control for both is tying agent access to sensitivity label. Public, unrestricted, general, tied to user identity, confidential, approval plus audit. Restricted, block by default. Left side, violating prompts, block before anything leaks. Right side, DSPM giving you visibility across all agents actively at scale. DSPM is your starting point, the place where a data security admin comes to understand what the biggest risks are and where to focus first. The objective every org keeps coming back to: oversharing. Sensitive data that too many people can access. DSPM makes that visible and gives you a clear path to fix it. Data risk assessment spans SharePoint, OneDrive, and Fabric, and shows you where sensitive data is sitting with more access than it should have. Volume, location, sensitivity, exposure, all in one view. It flags the overshared items, surfaces the key metrics, and points security team at exactly where to focus remediation. The practical value is prioritization. You are not looking at a sea of findings. You are looking at a ranked picture of risk. Fix the highest exposure sensitive content first, work your way down. Finding the risk is step 1. This is step 2, fixing it. Item level analysis, automated remediation actions, bulk disable overshared links, remove or tighten sharing permission, notify owners, apply sensitive label at scale, including from search. You can't protect what you can't see. That's the principle behind AI observability in DSPM. This view gives you coverage across every agent in your environment, first party and third party, showing you what they are interacting with and what they are doing with your data. So once an agent is flagged as risky, this is what the investigation looks like. You get the same depth of analysis that you would have for a human inside a case, a full sequence of everything that agent did. That's detail matter, because when something goes wrong with an agent, the question isn't just, did it do something bad? It's, what did it do, in what order, and what data was it moved? That's what lets you scope the incident, contain it, and explain it. This is Purview and Foundry working as one. The integration eliminates the gap between the team building AI and the team responsible for data security. Governance isn't a separate step. It's built into where the agents live. With that, let's move into the AI threat protection. We have covered identity, we have covered data. Now we are talking about what happens when things goes wrong, because they will. So this section is about detection, response, and protection, specifically designed for the AI layer. How do you see attackers coming? How do you see attacks coming? How do you respond when an agent behaves unexpectedly? And how do you build a threat protection posture that covers AI from the start? So let's talk about what actually needs protection, because the surface area is bigger than most people realize. Start with the human to agent layer. Every prompt a user sends, every response an agent returns, that's an interaction that can be exploited. You need to protect that channel, control who can access which agents, and prevents users from being the entry point for an attack. Then you have got agent to agent. When agents chain together, each connection is a potential oversharing event. Guardrails need to be in place so one agent can't pass sensitive data to another that has no business seeing it. Then there's the LLM layer itself. Model poisoning is real. If an attacker can influence what the model produces, they can influence what the agent does. And finally, every resource connection, every tool call, every API, every data access needs governance and real-time protection applied. Stack all of that together, and you have got genuinely expanded attack surface. And sitting on top of all 8 are the runtime threats: prompt injection, data exfiltration, and shadow AI that nobody has visibility into. So how do you actually defend against AI threats? This slide lays out the answer across few tools, and it's worth understanding how they fit together. First, discover and prevent before threats materialize. AI security posture management in Defender gives you continuous visibility into your AI attack surface. Red teaming in Foundry lets you proactively find where your agents and models can be manipulated before attackers do. Second, defend and block at runtime. Defender for Cloud and Defender XDR handles active threats across your environment. Content Safety and Prompt Shield in Foundry specifically intercept prompt injection and model abuse attempts in real time. Third, gain complete attack visibility. Defender for Cloud gives you the full picture. What can be targeted, what can be accessed, what the kill chain looks like. So you can respond fast and contain it. And fourth, enforce identity guardrails. Risk-based conditional access in Entra means that if an agent or a user's behavior looks suspicious, access gets stepped up or blocked automatically without waiting for a human to catch it. So multiple tools, each one address a different phase of how AI threat actually plays out. With that, let's move to a quick demo. In this demo, we will follow two personas, Cecil, the IT administrator, and Isaac, the SOC analyst, to see how they work together to identify and respond to an agent risk. As Cecil, I'm in the Microsoft 365 Admin Center on the Agent Overview page, and I want to understand any security risk associated with my agent. So I will select Manage Agent Risk. I can see several agents here, but I'm more interested on Customer Billing Agent. I can immediately see that it has active alert because Microsoft Defender has detected 2 security risks. As an IT admin, I only see unresolved high and critical severity alerts. At this point, I have enough information to know something requires attention, so I will ask my SOC team to investigate further. Now, let's switch to Isaac, a SOC analyst. Microsoft Defender is where I go for threat investigation, posture management, and incident response. Unlike the IT admin view, I have access to much richer investigation data. I will open the critical alert. From the incident summary, I can see this is a consolidated security incident involving a user and AI agent. Let's open the incident and investigate further. Here I can see multiple related alerts grouped together, including persistent jailbreak attempt against a Copilot Studio agent and a suspicious tool invocation activity that was blocked by Defender. Looking deeper, I can see that the same user repeatedly attempted to invoke email tool within a short period of time. So based on the incident evidence, this behavior looks suspicious and may indicate compromised credential. I will go ahead and mark the user as compromised so the appropriate response action can be taken. However, I don't want to just to respond to this incident. I also want to reduce the risk of similar incident in the future. To do that, I will use the advanced hunting to examine the agent's configuration. Here I can see additional details about the agent, including the tool invocation activity that Defender blocked. Defender provides a rich set of pre-built queries that help to accelerate investigation. This query shows me agents that have MCP tools configured using maker credentials. Now, it's clear that this agent's configuration could be improved. I can work with the agent owner to reconfigure permission and strengthen its overall security posture. This demonstrates how IT and security team can work together. IT admins gain visibility into agents' risk, while security analysts have the tools needed to investigate threats, respond quickly, and improve the security posture of AI agent across the organization. With that, I will hand over to Yuning to talk about red teaming.
Thanks, Dishan. Now we reached the last subject of the session, red teaming for agentic AI. The simple idea is we want to find the weak spots before attackers, users, or unexpected behaviors find them for us. Let's compare AI red teaming with traditional red teaming. Traditional red teaming usually look for weaknesses in physical security, networks, or information systems. AI red teaming still cares about security, but it also asks harder questions. Can the model be manipulated? Can the agent be pushed outside its purpose? And can the system produce unsafe or untrustworthy outcomes? A good approach is to run this in sprints. Pick the harms and features to test. Give red teamers clear instructions. Probe the product. Document what fails. And then work with stakeholders to reduce the risk. For agents, this has to be continuous. The reason is straightforward. Agents keep changing. A new prompt, a new tool, a new data resource, a model update, or a policy change can introduce a new weakness. So we red team across the lifecycle, before deployment to understand the threat model, pre-deployment to test the full experience, after deployment on the regular schedule, and when we need evidence for compliance. I like this quote. If you only red team before launch, you are only safe on launch day. This is especially true for AI agents. Let me show you the tooling that helps make this practical. Foundry AI red teaming agents helps make this easier to run at scale. It can automate adversarial probing with pirate-powered attack strategies, including prompt injection, encoding, and multi-step jailbreak techniques. It also scores the risk, tracks findings, and produces reports that teams can use for mitigation and compliance. To make this useful in the real world, your teams need a practical cadence. A reasonable cadence example is monthly automated scans, quarterly expanded scans with new attack patterns and some manual review, event-driven scans after major changes, and annual deeper exercise. The most important thing is to track results over time. That way, you can see whether the risk is going down, coming back, or moving to a different part of the system. All right. With that, we've covered the 8 subjects on trust, compliance AI system at scale. Let's wrap up with the key takeaway. Security and trust are not optional. They are the foundation of production AI. Here are the takeaways I will leave you with. First, agentic AI expands the attack surface because agents use tools, memory, autonomy, and often spread quickly across the organization. Second, zero trust still applies, but we need to extend it to agents and AI resources. Third, responsible AI has to become practical controls, not just principles. Fourth, observability is what turns signals into action. Fifth, identity is the foundation of agent trust. Sixth, data protection has to follow every interaction, not just sit around the data store. Seventh, runtime threat protection needs to defend agents like users, and in some cases even more carefully. And last, red teaming is never finished. It has to keep pace with change. Let's finish with the broader workshop session. Put together, this is what production readiness looks like. Governance from the AI COE, secure infrastructure from the landing zone, trust boundaries from the agent architecture, operational monitoring from the agent ops, and the security controls from this topic. To close the content, I want to quickly connect this topic back to the full session. Security and observability are not separate work streams. They are the thread running through the AI COE, the landing zone, agent architecture, agent ops, and FinOps. The practical takeaway is simple. Define the guardrails, deploy on the secure foundation, give agents clear identity and trust boundaries, monitor what they do, and treat unusual activities and cost spikes as signals to investigate. This gives you a repeatable way to move from experimentation towards production with confidence. That brings us to the end of the session. For questions, please use the webinar chat. We'll keep the Q&A there so everyone can follow the discussion and we can respond in one place. Thank you for joining, and we appreciate your participation in the AI Path to Production webinar series, and we look forward to seeing you again in future events.